All right, y'all. So like I said, this will be 8.3 support. So we're going to deal with polynomial division. And the method we're going to be concerned with is what we call synthetic division. Now, we'll use synthetic division for three things today. We'll find the remainder and quotient. So we'll find the quotient and remainder. All right, so we'll take a polynomial, divide by another one. We'll find our quotient and remainder. Then we'll do this in the support part. Okay, so there's three problems in support, and that's what we're doing. Now, the second thing and third thing I use it for will be more into the college algebra. But I can find function values. So like f of 2, f of 3, and stuff like that. If I'm given a polynomial, I can find function values. And then the third thing I can use it for, I can use synthetic division to test if a number is a zero of a polynomial. So I can check if a number is a zero of a polynomial, okay? So we'll start with finding the quotient and remainder. So this will be the support part of this lesson, okay? So I'm going to actually give you the steps for synthetic division first. Alrighty now. So what I'm going to do, I'm sort of going to work a problem over here on the side and show you how this synthetic division works, okay? So over here on the side, um, I'm going to take, say, x squared plus 7x plus 10, and I'm going to divide that by, let's see, I'm going to divide that by x plus 2. So I want you to sort of see the steps as I'm describing them over here. So the first thing you do, we're going to write the coefficients of the polynomial. So the coefficients of the polynomial I'm talking about are this first polynomial here. So the coefficients would be the 1, the 7, and the 10. Now here's the thing on this section, y'all. Notice I got my x squared term, my x term, and my number. But if any of these terms were missing, we would have to use a zero in their place. So we use a zero for any missing terms, which I wasn't missing any. I had my x squared term, my x term, and my number. Y'all hang on just a second. All righty. So got my coefficients written. Next, I'm going to draw a line under the numbers. So I'm going to draw a line under coefficients. Leaving space underneath. Now, I'm going to leave space in here. So I'm going to draw me a line. And then you're going to box under the last number. So make a box under last number. So what's going to happen, the stuff left over here will be the quotient. The stuff in the box will be the remainder, okay? So y'all, this part gives me the quotient. And then this part right here will be our remainder. All right, so next I get what we're dividing by. We call that C. So C is what we're going to be dividing by. So you write C to the left. Now here's the thing. When you're finding quotient and remainders and they give you the number in factored form, this number is how I get C, but if it's in factored form, you got to change it from a +2 to a -2. Because you're actually dividing by what we call the zeros. So remember, if it's in factored form, change the sign. So we're going to change the sign since in factor form. So if you're dividing and your number is in a parentheses, you got to change it to the opposite sign. All righty. Now we actually start the process of the synthetic division. This is just getting it set up. You got your numbers. All right, you got your numbers, you got your C, and then this will be our quotient and remainder. So y'all, here's what you do. Bring the first number down. Below the line. So bring the first number down below the line. So the first number is the 1. You're going to bring that 1 straight down and put it below the line here. All right. So the first number always comes down. Then what I do, I take the number I brought down, multiply by the C, and put that number in the next column. So take the number you brought down, and multiply by C. Put answer under the number in the next column. All right, y'all, so watch what we're going to do. This number I just brought down, I'm going to multiply by C. So 1 times -2 is -2. So I put that in the next column under the number. So 1 times 2 is -2. So now I've got a full column here. So next what I'm going to do, I'm going to add that column together. So add the column and put the answer below the line. So if I have a positive 7 added to a negative 2, that's going to give me a positive 5. So now the 5 is down here below my line. So my next step, I'm going to repeat the process. So repeat process until done. All right, so to repeat the process, this 5 now gets multiplied by the C. So I got 5 times negative 2 is negative 10. Once I got my column, I add this. 10 and negative 10 give me a remainder of 0. So y'all, this quotient here, this quotient is the coefficients of the new polynomial and it starts out 1 degree less than the original polynomial. So what I mean, remember the degree is the highest exponent. So if you started out with a x to the second, this is the quotient, and these are the numbers of it, but it starts out 1 degree less than the original. So if this was an x squared, that means this will be an x plus 5. So 1x plus 5. So my quotient is x plus 5. Okay. My remainder is 0. So y'all, I'm just showing y'all a basic one here just to get you going. So I'll actually show you all 3 of the ones in support, okay? But this is the process. So remember, all these numbers give you your quotient. The number in the box gives you your remainder. Okay, so we write out the coefficients of the polynomial, 1, 7, 10. We find our C. And remember, when we're in factor form, the C always has the opposite sign. So that was negative 2. So the process of synthetic division, I brought the first number down below the line. Any number down here gets multiplied by C to get the next column. So I did 1 times negative 2, gave me negative 2. I added that, got 5. Then I repeated, multiplied by negative 2, got my negative 10. Then I added and got a 0 remainder. So y'all, what we're going to do now, let's play with the support questions. And then after we do the support, we'll do the college algebra. So the support had 3 questions dealing with finding the quotient and remainder. And I'll show you different ways they write the answer on this, okay? All right, so y'all, these 3 examples will say use synthetic division to find the quotient and remainder. All right, so support number 1 had w to the 3rd minus 6w squared plus 24w minus 20 divided by w minus 4. So I'm going to write my coefficients first. So there's nothing missing. I got my W3, I got my W squared, I got my W, and I got my number. So there's no missing terms. So let's write down our coefficients. We got a 1, negative 6, 24, and a negative 20. All right, leave a little space and draw your box, your line, and then box under the last number. All right, so over here will be what we call our C. So remember, this is in factored form, W minus 4. So C will be the opposite of the negative 4. That'll be a positive 4. And y'all really, the only time you got to change these signs of the number is when it's in factors, okay? All right, we got what we need written out. So here we go. We're going to bring the first number down below the line. Then we'll multiply to get the next column. So 1 times 4 is 4. Add this column now. Negative 6 plus 4 gives me a negative 2. All right, so what I do now, I multiply by C and get the next row. So negative 2 times 4 is negative 8. All right, y'all, 24 and negative 8 give me a positive 16. So now I multiply by C again to get my last column. 16 times 4 is 64. 64 and a negative 20 give me a remainder of 44. So this part right here is my quotient. This right here is my remainder. Now we said the quotient started out 1 degree less than the original. So if the original is a W to the third, this will be a W squared. So I got 1W squared minus 2W plus 16. So you start 1 degree less and then you just keep going in descending order. W squared, W, number. Now, I got a remainder of 44. Now, y'all, I'm going to show you another way they could write these answers. One way they do it, they write it out and put remainder of 44. The other way, they write it as a long polynomial. W squared minus 2W plus 16 plus, they write the remainder as a fraction in the other style. So to write the remainder as a fraction, you take the remainder, which was 44, and you put that over what we divided by, which was the W minus 4. And y'all, these ones are pretty much multiple choice. So you'll either see if they're writing the remainder out as a number like this, or you'll see the answers where they write the remainder out as a fraction, okay? But either way. So just look for what they're doing on them, okay? All right, y'all, so that's your answer. So that's why I like this synthetic division. You're just moving the numbers around and then you put them back in what you need once you're done with these numbers, okay? So y'all, the same thing on this one. 2b to the third plus 14b squared plus 21b minus 20. We'll divide that by b plus 4. All right, so always check and see if anything's missing. So b third, b squared, b number, nothing's missing. So let's write out our coefficients. We got a 2, 14, 21, and a negative 20. All right, I'm going to draw my box under my last number. All right, my C, since that's a b plus 4, My C, will be a -4. So up here it was -4, I made it positive. Here it's positive, I made it negative. And y'all, like I said, we're only going to change the signs when they're in factored form, okay? When I use it to find function values and checking to see if a number is a zero, on those ones, I won't change the signs, okay? Only on these when they're in factor form. All right, y'all, so we're set up. So guess what? First number comes straight down, bring down that 2. You're going to multiply to get to the next column. 2 times -4 is -8. You're going to add this row, 14 and -8, give us a 6. All right, repeat the process, multiply. 6 times -4 is -24. Add that column, -24 plus 21 gives you a -3. And y'all repeat the process. -3 times -4 is a +12. And y'all, -20 plus 12 gives us a remainder of -8. So once again, it's going to start 1 degree less than that 3. So that means I got 2b squared plus 6b minus 3. And then I got a remainder of -8. Now, if you want to see that one in the other form, they would have 2b squared plus 6b minus 3 plus -8, which is your remainder, over the b plus 4 you divided by. Okay, y'all, so that's what you just got to watch out for. Which way are they writing your answer choices, okay? All right, y'all, so notice these two, I didn't have any missing terms on those. So I want to do one with you where you do have a missing term. So the last one for support, I got an a to the third minus 4a squared plus 9 divided by a minus 2. So y'all look here, I got an a to the third, a squared. I don't have an a term, and then I got my 9. So I'm missing the a term on this one. So we're missing the a term because we got the a squared and a cubes and all that fun stuff. So that means when I write out the coefficients, I got to put a 0 in that placeholder. All right, y'all, so here we go. A cubed, I got 1a cubed minus 4a squared plus 0a, and then plus my 9. I'm going to write my line and box under the last number. Okay, so if you got an exponent 3, you add 1 and you need 4 numbers. If you got an exponent 2, you add 1, you need 3 numbers. Add 1 to the biggest exponent, and that tells you how many numbers you need, okay? All right, over here, my C, since this is a minus 2, my C will be a +2, okay? All right, so the biggest thing on this one was to realize that you did not have enough terms up here, okay? Because you always got to have your number, your x term, x squared, x cubed, x4, and so on, okay? All right, y'all, let's get it going. So the first number always comes down below the line. And then we're going to start our process. 1 times 2 is 2. That goes in the second column. -4 and 2 add up to get me a -2. All right, -2 times 2 is -4. Add this column now, 0 and -4. Give me -4. And then finally, -4 times 2 is -8. 9 and -8 give me a +1. So I could write this, remember, 1 degree less, that's an A3, so this will be 1A squared minus 2A minus 4, and my remainder equals 1. Or remember, I could do A squared minus 2A minus 4 plus 1 divided by A minus 2. Okay, so it depends on how they write the answers as to who you're going to choose, okay? So that'd be 1 over what I divided by, which was the A minus 2. Okay, so support was mainly dealing with finding the quotient and remainder, okay? And y'all, what I like about synthetic division, once you get it down, it's the same every time, okay? All right, so 8.3 college algebra, polynomial division. So like I said, we can use it for 3 things. We done used it for 1. We found the quotients and remainders. So next, we're going to use synthetic division. To find function values. So when using synthetic division to find function values, all right, let me let one in real quick. So when using synthetic division to find function values, go check this out. The function value is equal to the remainder when using synthetic division. Okay, and that's what we call the remainder theorem, is that the function value is equal to the remainder when using synthetic division. So I'm going to do one by hand that we should figure out, and then we're going to see that synthetic division gives me the same answer, okay? So here's the old way. We're going to find f of 2 given f of x equals 3x squared plus 4x minus 7. Let's do this by hand real quick, see what answer we get, and then we'll do it the synthetic division way and see what answer we get, okay? So by hand, and we've been doing this all year. So to find f of 2, I'm going to put a 2 in for these x's. So y'all get 3 times 2 squared plus 4 times 2 minus 7. So notice, doing it this way, I got to follow the order of operations. So bring that 3 down. The first step is the exponent. So 2 squared would be 2 times 2, which is 4. All right, I'm only doing that one step, so I'm bringing everything else down. So I did the exponent first. That 2 squared turned into a 4. Now I'm going to multiply this 3 by 4 and get 12. Plus 4 times 2 is 8. Minus my 7. All right, y'all. 12 plus 8 is 20. Minus 7 gives me a total of 13. All right, so by hand, f of 2 gave me 13. Now let's do it the synthetic division way. All right, so I got my polynomial. So for synthetic division way, I'm going to write my coefficients. Nothing's missing because I got my x squared, my x, and my number. So write your coefficients, which will be 3, 4, -7. You're going to draw your line and box under the last number. Now, since I'm finding f of 2, this is not in factor form. They're just wanting me to find f of 2. So when they give you the number in this format, we do not change the sign of the number. We only change the sign of this number when it's in factor form, x minus 2, x plus 2, and so on, okay? But y'all, what I want y'all to pay attention to is what answer I get in that box. So, bring the first number down below the line. Then you're going to multiply. 3 times 2 is 6. Put that in the next column. You're going to add 4 and 6 and get me a 10. You're then going to multiply 10 times 2 and get 20. Oh, and y'all look at that. 20 and a -7 give us a positive 13. So look how that remainder gave me the same answer as plugging that 2 in for all these x's. Okay, so I just wanted y'all to see that either way I work it, I got the same answer on that, okay? So let's start doing some of this college algebra homework, finding function values. So y'all, I'm going to use synthetic division to find the function values. All right, so notice what they're giving me. F of x equals x to the third minus 13x squared plus 52x minus 60. So they want me to find f of 2, f of a -5, and f of 6. So basically 3 problems on this one because they want me to find all 3 of these function values. So I'm using the same coefficients every time though, okay? So let's see, nothing's missing. X3, x squared, x, and a number. So I got a 1, -13, 52, and a -60. I'm going to leave me a little space and draw my line. Now the first C is the first number I'm finding the function value of. That is a 2. And then next time I'll do the -5, and then I'll do that -6. So F of 2 is going to equal whatever that remainder is. So y'all, here we go. We bring the first number down. 1 times 2 is 2. We put that in the next column. Negative 13 plus 2 is negative 11. All right, repeat the process. Negative 11 times 2 is negative 22. All right, add this column. 52 and negative 22 gave me a 30. All right, 30 times 2 is 60. And adding the negative 60 and 60, I get a remainder of 0. So that means f of 2 equals 0. You would have got the same answer as a 0 if you'd have put a 2 in for all three of them x's, okay? All right, now let's try f of negative 5. So my new c is negative 5. I still got the same coefficients. 1, negative 13, 52, and negative 60. All right, y'all, so let's see what we get when we put a negative 5 in for all these x's. So once again, I'm bringing the first number down, and then I'm going to start my process. 1 times negative 5 is negative 5. Negative 13 and negative 5 give me a negative 18. Negative 18 times negative 5 is a positive 90. You got to watch these signs on these things is the big thing. All right, y'all, let's see. 52 and 90 give me 142. 142 times a negative 5 gives me a negative 710. Whew, I'm getting a big number on this one, but if I add negative 60 and a negative 710, I get a negative 770. So that's the same answer I would have got if I'd have put negative 5s in for all these x's. So f of negative 5 equals a negative 770. All right, y'all, one more to go. I got to find f of 6 now. So let me put me a 6 here. Still the same coefficients. 1, negative 13, 52, and negative 60. All right, y'all, so once again, I'm looking for that remainder. So if you've noticed the pattern of the day, the first number, we're bringing down below the line. All right, 1 times 6 is 6. Negative 13 plus 6 gives you a negative 7. Negative 7 times 6 is negative 42. 52, negative 42, leave you 10. And y'all look at that. 10 times 6 is 60. And negative 60 and 60 give me a remainder of 0. So that means f of 6 equals 0. Okay, so I got a 0 for one answer, negative 770, and then a 0. So y'all, that's the trick when you're looking at synthetic division. So let me pull my next one out here. All right, y'all, so let's do one more. And then we'll probably be getting into break time on this one. All right, this one's like number 2. Do synthetic division, find the function value. So they're giving us f of x equals x to the 4th minus x to the 3rd minus 13x squared plus 49x minus 25. They want me to find f of 4. Whoops, y'all, I didn't know my page wasn't up. All right, so they're giving us for number 2, f of x equals x to the 4th minus x to the 3rd minus 13x squared plus 49x minus 25. So funny, someone didn't tell me to pull that up. Are y'all on here today? All right, y'all. So let's see if anything's missing. X4, X3, X squared, X number. Nothing's missing, so let's write out our coefficients. We got a 1, a -1, -13, 49, and a -25. Draw my line, put my box. My C, what do they want me to find? F of 4. So we put a 4 in, okay? So it's not in factored form. So y'all, I've done 1, 2, 3, I've done about 6 or 7 examples doing this. I'm going to give y'all about 2 or 3 minutes, and one of y'all tell me what the function value is. What does f of 4 give me? All right, y'all, so that is on y'all to figure.
That's an x to the 4th minus x to the 3rd.
Mm-hmm.
Okay.
So x to the 4th minus x to the 3rd minus 13x squared plus the 49x minus 25. And then y'all would write y'all's coefficients out. So we had 1, 2, 3, 4, 5 places here with nothing missing. So I had my 5 numbers. So let me ask y'all this. What's my first number? I mean, my first step. What's my first step on this? Hey, also follow me because I'm gonna make y'all do the next one for sure. Watch what I do. Your first step is to take the first number and bring that thing down below that line. Now, any number that we bring below the line gets multiplied by the C and put into the next column. So watch this. You're taking this number times the 4. So 1 times 4 is 4, and you're putting that into the next column. Now, numbers in the column get added. So remember, add the columns. Okay. So a -1 and a 4 should give y'all a 3. All right, so the 3 is now below the line. So we're going to repeat the process again. This 3 is going to multiply by that 4. So 3 times 4 will give me 12. That goes into the next column. All right, now remember we said you add the columns. So what's a -13 and a 12 is going to give us a -1. All right, so the -1's below the line again. So now I'm going to take that -1, multiply by that 4. So everything's getting multiplied by the 4. So -1 times 4 makes that a -4. All right, so I need to add this column now. Well, 49 and -4 give me a 45. All right, so I still got one more step to go. I got to take this 45, multiply by 4, which gives me a 190. And once I add that column, I will have my answer, okay? So I think that's what, 165. There you go. So y'all, that means f of 4 equals 165. The same answer you would have got had you physically put that 4 in for all these x's. But y'all, tell you the truth, I think this synthetic division is a lot easier than putting numbers into these. I mean, the calculator can do them quick, no doubt, but by hand, they get a little tricky. All right, so that was using synthetic division to find function values. Next, we're going to use synthetic division to determine if a given number is a zero of a polynomial. Now you got to remember this. Zeros are the answers to the polynomial or the solutions. So we can use synthetic division to determine if a given number is a zero of that polynomial. So if a number is a zero of a polynomial, then the remainder must be zero. So once again, if it's a zero, it's got to have an answer of zero. Just like all those solutions we've been doing this year. There's a lot of things we want y'all to realize about zeros. We want y'all to realize that zeros are equal to the function value of zero when doing synthetic division. You set equations equal to zero to solve them. The zeros were equal to the x values of the x-intercepts. So there's a lot of ways to find these zeros, okay? This is just giving you more ammunition for these problems, okay? So if it's going to be a zero, my remainder has to be zero. So y'all, here we go. Using synthetic division, determine whether the numbers are zeros of the polynomial. Okay, so these will start at number 3. So the numbers they want me to check, -3 and 2. And then they're giving us f of x equals 2x to the third plus 3x squared minus 5x plus 12. Oh, y'all, I'm showing break time, so let's knock out a break real quick. I'm showing 10:52. So we will take a break and then we'll come back and knock out the last three out of this. And then I'm just going to show y'all how to do a few things to get us ready for tomorrow, okay? So y'all, I'm going to stop my share, cut my video out for a second. Okay, so we left off on this number 3 here. They want me to determine if -3 and 2 are zeros of this polynomial. And y'all remember we just said, if these are zeros, then the remainder must be 0. So I'm going to look for a 0 remainder. If I get a 0, yes. Any other number, no. All right, so let me write my coefficients. Nothing's missing. X3, x squared, x, and my number. So I'm going to write my coefficients. 2, 3, -5, and 12. All right, box under the last number. All right, so the first number we're checking is -3. And we do not change the signs of it because it's not in factor form, okay? All right, so -3. If I get a 0 remainder, I'm going to put yes. So y'all, here we go. Bring the 2 down. Then we're going to multiply, add until we're done. So 2 times -3 is -6. 3 plus -6 is -3. -3 times -3 is 9. 9 and -5 is 4. 4 times -3 is -12. And y'all look at that. 12 and -12 give me a remainder of 0. So since I got a remainder of 0, yes, -3 is a 0. So now we got to check 2. So 2 is the next number I'm going to check. So I got the same coefficients, 2, 3, -5, and 12. All right, so once again, we're looking for a 0 remainder for yes. Any other number? No. All right, y'all bring the first number down. 2 times 2 is 4. 3 plus 4 is 7. 7 times 2 is 14. -5 plus 14 is 9. 9 times 2 is 18. And at this point, I know I'm not going to get a 0 because 12 and 18 give me 30. So since we got an answer of 30, that means no, 2 is not a 0. Now on I think on the answer when you say no, it's not a 0, you got to put y. So no, 2 is not a 0 because f of 2 equaled 30. And over here, yes, -3 is the 0 because f of -3 equaled 0, okay? All right, y'all, so let's try the next one. And y'all, that's all these last 3 are doing is just checking to see if they're zeros or not, okay? So this is like number 4. Same thing, using synthetic division. Determine whether the numbers are zeros of the polynomial. All right, so same thing. This time they're giving me -1 and 1. And my polynomial is f of x equals x to the fourth plus 2x to the third plus 2x squared minus 6x minus 7. So once again, two more numbers I gotta check. So let's see if anything's missing. X4, X3, X squared, X, and a number. So nothing's missing. So let's write out our numbers. 1, 2, 2, -6, and -7. All right, I'm gonna draw my line. Box under the last number. And y'all, the first number I'm gonna check is the -1. So I'll do this, and then over here, I'll check the +1, okay? So let's see if this one's a 0 or not. Bring the first number down, and then we're going to multiply, add until we're done. So 1 times -1 is -1. 2 and -1, give me 1. 1 times -1 is -1. 2 and -1, give me 1. 1 times -1 is -1. -6 plus -1 gives me -7. And y'all look at this. -7 times -1 is a +7. -7 and 7 equal 0. So that means, yes, -1 is a 0. All right, so now we got to check 1. We got the same numbers. 1, 2, 2, -6, -7. All right, so let's see if 1 is a 0. So bring the 1 down. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. 2 plus 3 is 5. There y'all. 5 times 1 is 5. -6 plus 5 is -1. And y'all, I don't think we're getting a 0 because -1 times 1 is -1. And then -7 plus -1 is -8. So we got a -8 remainder. So that means no, 1 is not a 0. All righty, y'all. So let's try this number 5. It's probably the trickiest one of them all. But they want to know, they want us to determine whether a -3/2 is a 0 of the polynomial. So my polynomial is f of x equals x to the third plus 5/2 x squared plus 13/2 x plus 15/2. So they're breaking out the fractions on us. Let's see if anything's missing. X3, x squared, x, and our number. So nothing's missing. So let's write out these numbers. We got a 1, 5/2, 13/2, and 15/2. Now I'm going to leave a little bit extra room because these are fractions. So I'm going to bring my line down to here and box off my last section. And y'all look at my C. My C is a fraction. It is a negative 3/2. Now, I would say I'm happy they all got a common denominator at least, you know? And we got a nice calculator that can help us add fractions, okay? And multiply fractions. So you can do all that on the calculator too, okay? So here we go. We bring the first number down. Now we take the 1 times negative 3/2. That's going to give me a negative 3/2. Now y'all can do this on the calculator, 5/2 minus 3/2, and that'll give you a simplified answer. If you're doing it by hand, 5/2 minus 3/2. Since they got a common denominator, you bring that over, and then you do the adding and subtracting on top. 5 minus 3 gives me 2. And y'all, 2 over 2 reduces to a 1. Okay, so you can do that on the calculator and you'll still get a 1 like I did. Now, 1 times negative 3/2 is a negative 3/2. So now you got 13/2 minus 3/2. So bring the common denominator over. 13 minus 3 gives me 10. And y'all, 10/2 will reduce to a 5. So 13/2 minus 3/2 gave me 10/2, which reduced to a 5. So now you got to multiply this 5 times that negative 3/2. So 5 times negative 3/2. So when you got a number like this that don't have a denominator, you treat it like it's got a 1 on the bottom. Top numbers multiply by top numbers. Bottom times bottom. So if you got a single number here like a 5, it only multiplies by the top. Okay? So 5 times negative 3 gives me a negative 15. 1 times 2 is 2. So 5 times negative 3/2 gave me a negative 15/2. And y'all look at that. 15/2 minus 15/2 gives me a remainder of 0. So this would be a yes. So y'all, that's the trick with 8-3 is synthetic division, okay? Now, what I'm going to do, since I got a little bit of time left, I'm going to get us ready for tomorrow, because tomorrow we're going to be doing a lot of foiling and stuff. So I'm just going to give you a little bit of foiling practice. So there's no homework problems doing this. I'm just doing this to get y'all ready for tomorrow, okay? So we've seen how to FOIL stuff like x plus 5 times x minus 2. So let me go over basic foiling. I do x times x and get an x squared. I do the x times negative 2. I get a negative 2x. I do the 5 times x and get a positive 5x. And then y'all, I do the 5 times negative 2 and get a negative 10. Last step, I would add the like terms. So bring down the x squared. Negative 2 plus 5 gives me 3x and then my minus 10. So this is basic foiling. Okay? But what I want to do with y'all is get y'all ready for tomorrow by foiling something like this. X plus 3i times x minus 3i. We're going to foil imaginary numbers. Now, the thing you got to remember when you foil imaginary numbers is that if we get an I squared equals -1. If I get an I squared, I got to replace that with this -1, okay? And y'all, if you want to punch that on your calculator, watch this. You see down here by the decimal, there's a blue I. So if I do second decimal, it pulls up the I. And I'm going to multiply that times another one. Second decimal. Whoops, let me delete that one extra dot there. All right, so I got I times I, which is I squared. But watch what that equals. It equals -1. Okay, so you can multiply the I stuff on the calculator. So watch what happens when we FOIL this. You get x times x, which is x squared. And y'all, I want y'all to notice, these are conjugate pairs, x plus 3i, x minus 3i. They're exactly the same other than one's being added and one's being subtracted. Anytime we FOIL conjugate pairs, the middle two terms are going to cancel. So remember, these are conjugate pairs. And that even works with regular numbers, and I'll show you that also. All right, y'all. Now the x times -3i is a -3ix. So now we distribute the 3i times x. I get a positive 3ix. But y'all be careful here. 3i times -3i is a -9i squared. So you got a few things going on. What happens there? A -3i, positive 3i, those cancel. This negative I squared. What I say I squared equals? Well, y'all, we said I squared equaled -1. So this becomes x squared minus 9 times -1. So remember, I turned the I squared into a -1 based on that definition right there, okay? So this becomes what? An x squared, negative times negative, makes that a +9. So when you FOIL imaginary numbers and they're conjugate pairs like this, it's going to end up x squared plus the number, okay? And y'all, I'm going to do another one of these just so y'all see these patterns. Let's do something like x minus 7i and x plus 7i. I want y'all to see how these work every time. And since these are imaginary numbers, they're going to end up positive, okay? All right, y'all, so here we go. X times x is x squared. X times 7i is a 7ix. -7i times x is a -7ix. And then finally, -7i times 7i is a -49i squared. So do y'all see the same thing that happened here is happening here? the 7i, negative 7i are going to cancel. This I squared, we're going to turn it into a -1. So that's going to give me x squared minus 49 times -1. And basically, that's just going to make them a positive. So you get x squared plus 49. So I squared's only purpose really in life is to change the sign of the number in front of it. If the number in front of I squared is negative, it's going to become positive, okay? So y'all, that's a little bit of practice on foiling imaginary numbers. What about stuff like this? X plus square root of 3 times x minus square root of 3. This is radicals. So for radicals, you got to recall one thing about radicals. A square root of a times a square root of a equals a. So if I multiply square root times itself, it equals the number that was under that square root. So I got a square root of 3. When I multiply square root of 3 times square root of 3, I'm going to get a 3. Okay? Now I'll work them out the long way so that you'll see that. But in the long run, that's what's happening, okay? Now, these are conjugate pairs. Because one's plus, one's minus, everything else is the same. So since they're conjugate pairs, the middle two things are going to cancel out like both of these conjugate pairs did, okay? Oh, y'all, watch this. X times x squared. X times a negative square root of 3 is a negative square root of 3 times x. The x does not go under the radical. Things on the outside cannot multiply by things on the inside of the radical, okay? So the x has to stay on the outside. All right, same thing here. Square root of 3 times x is a positive square root of 3 times x. And y'all watch this one. Plus times a minus makes that a minus square root. Now this 3 is underneath, this 3 is underneath. So technically I can multiply them. 3 times 3 is 9. All right, so y'all are seeing this right here. Those are going to cancel. Negative square root of 3, positive square root of 3 cancel. Bring down to x squared. That's going to be minus. Well, guess what? Square root of 9 is 3. So that goes back to this. Square root of 3 times the square root of 3 equaled a 3, okay? Oh, y'all, so let me do another one or two of these. Hopefully this is bringing back memories. So let's see, I did plus and minus. How about if I do x minus square root of 2 x plus square root of 2. So y'all, this, like I said, there's no homework doing this. I just want y'all to see a bunch of examples of this stuff before tomorrow, okay? All right, y'all, so here we go. X times x is x squared. X times the square root of 2 is a square root of 2 times x. And then we start on the center. Negative square root of 2 times x is a negative square root of 2 times x. And then finally, negative square root of 2 times a positive square root of 2 is a negative square root of 2 times 2, which is 4. But we know at that point, we could have just put the a, which would have been the 2, okay? All right, I'm gonna cancel out the middle. So I bring down my x squared minus my square root of 4, which is 2. So y'all, if you notice, if it's conjugate pairs, you can basically almost shortcut these and get the final answer. You can multiply the first two together and then the last two together to get to these answers. Because x times x is x squared. Negative square root of 2 times square root of 2 basically ends up as being a -2. Same thing with the imaginary. X times x is the x squared. -7i times 7i is a -49i squared, which turns into a +49. So I want y'all to see up here, these were not conjugates, so my middle stuff didn't cancel. But all the rest of these problems, they were conjugate pairs, and that's why the middle stuff always canceled on them, okay? So do y'all got any questions on that? All right, y'all. So tomorrow we'll pick up in 8-4, and we're gonna let me just give you one preview of tomorrow. Something you're gonna have to do. All right, y'all, let me pull this back up here. So y'all, this will be my last one. But notice this is 3 factors. So watch what I do when I got 3 factors. I'm going to start out by foiling the first 2 of these. Okay, so this is coming tomorrow. So I'm going to bring the first one down to x plus 1. And I'll get my parentheses ready for this stuff. And I'm going to foil that on the side. X plus 2 times x minus 5. So foil these two on the side. So x times x is x squared. X times -5 is -5x. The 2 times x is 2x. And then the 2 times -5 is -10. Got to add like terms. So I get x squared. -5 plus 2 is -3x minus 10. So that's what these two equaled when I foiled them. So put that in here. X squared minus 3x minus 10. But check this out. I still got the x plus 1 in the front. This x plus 1 now gets multiplied by all of this. So this is going to foil, but it's a little bit more to the foiling, okay? You're going to take this x times all 3 of these. X times x squared, add exponents. 1 plus 2 gives me an x to the third. Then that x times that -3x gives me a -3x squared. Then this x times this -10 is a -10x. So you distribute the x times all 3 of these. Then you're going to distribute the 1. 1 times x squared is x squared. 1 times -3x is a -3x. And then that 1 times -10 is a -10. So when you multiply two things times three, you get six things out here. When you did two things times two things, you had four terms. So ever how many times how many tells you how many terms. Um, and now I got to combine all these like terms. So bring down the x to the third. Negative 3x squared adds to the positive 1x squared. So negative 3 plus 1 gives you negative 2x squared. This negative 10x adds to that negative 3x. So negative 10 plus a negative 3 is a negative 13x. And then at the end is your minus 10. So 3x's, you ended up with an x cubed. 2x's, you ended up with an x squared, okay? So y'all, we're going to get to do this kind of fun stuff tomorrow. We're going to throw some of these might be imaginary. Some of these might be radicals. So the story of tomorrow is going to start out doing a lot of foiling, okay? And y'all, I really wanted y'all to see examples of the imaginary conjugate pairs and the radical conjugate pairs, okay? So play with that stuff if you want to get ready for tomorrow. But y'all, for today, we only did what? 8-3 support and 8-3 college algebra, okay? But y'all also remember, y'all got a test two open that is due by Sunday night, okay? And y'all, listen, what y'all need to do is when y'all do these tests and you're missing some, go back and look at why they're being missed. Okay. I went in and if I find where y'all got the right answer, but you didn't write it in the right form, I'm going in and giving y'all credits for some of those, okay? So if your
Some of
test,
them, I
what
didn't
now?
put I didn't put the parentheses around some of them, and it counted me wrong on it. But I went back and did it on the second attempt.
Okay, so you fixed it before your second attempt.
Right? Yes, sir.
Okay, okay. So I'll look at the better test, and if I see anything else, I'll give you credit. I'll look at your highest attempt. Um,
Okay.
Miss Johnson, you had a few that you forgot to put the x equals or whatever, so it marked you wrong, and you had the right answer, so I gave you credit on some of yours. And I think she actually forgot parentheses also, so I gave you credit on one of those too. So yeah, if y'all got the right answers in there, I'll give y'all credit, okay? So I'll look at yours for sure and see if everything was good on that set. But I think your second one was a lot better than your first one.
Yeah, mine was extremely better.
Yeah, that's what I was thinking too, okay? All righty, y'all. So do y'all have any questions?
No, no, that was about it.
All righty. So y'all let me stop my recording here.